Hello, Assalamualaikum and good morning to all. Okay, welcome back to our physics online classes revision for SPM, and Alhamdulillah, this will be our 9th lesson, and I would like to thank you very much for your effort and determination on joining this lesson. Okay, class, I hope you already have a good breakfast, and please be prepared with your module. Okay, as for today, we are going to continue our discussion on module 2, which I have posted to you earlier in your WhatsApp and Telegram group. Okay, so how much of you have tried this module? Can you please respond to me in the live chat? Have you tried at least one or two of these questions? Anyone? So who is with us today? Okay, now we have 13 people. Can you say hi in the live chat? Okay, how many of you have tried this module 2, which we are going to discuss today for question number 1 until question 9? Okay, so in the first module, the module are stressed on forces and motion, forces and pressure, and also heat. And for this module, module 2, it will be focused on light, wave, and electricity. And for question 1 until question 9, it will be on light and wave. So for those who are considering weak in these two chapters, I hope you can give your fully focus on this discussion, because these questions which consist in this module are the most frequently asked question in the SPM, and some of them actually is the actual past year SPM questions. Okay, so if you are ready, so let's begin our discussion today with question number 1. Okay. Okay, first of all, can you please respond to me, class, if you can hear me clearly? Because it seems that I have some problem with my mic here. So if you can hear me clearly, can you please respond in the live chat? Okay, thank you Husna, thank you Jin Jian. Okay, for those who are outside from Bagan Jaya, I would like to welcome you. Thank you very much for joining us, and you can get the module which I prepare in the description section, in the video description, so you can get and download it from there. Okay, so without any further delay, let us begin our discussion with question number 1. Okay, I believe some of you are familiar with this kind of question. It discusses on, the question is on light. Okay, so in diagram 1.1, you can see it shows a table clock which is placed in front of a plane mirror. So you can highlight plane mirror. And it says that the image of the table clock can be seen behind the mirror. Okay. First question, name the phenomenon involved in producing the image. So what is the phenomenon occurs here? Remember, our keyword is a plane mirror. So what light phenomenon involve mirror? So you can share your answer in the live chat section. The name of the phenomenon will give you 1 mark. Okay, so what are they? Okay, what is the answer? Okay, Jin Jie has typed it there. He says reflection of light. So what about the rest of you? What do you say? If possible, you please try to participate actively in this discussion, because I found that it's always the same person who are responding. Okay, so answer say reflection. So yes, very well. The answer is reflection of light. Okay, phenomenon is reflection of light. Remember, when you are deal with mirror, it always to do with reflection. It doesn't matter either plane mirror, concave mirror, or convex mirror. As long as it is a mirror, so the phenomenon is reflection. Okay, now question B. Based on diagram 1.1, state one characteristic of the image produced by the mirror. So what can you say about the characteristic of image produced by plane mirror? Actually, you have more options here. You can write more than one characteristic, but it only asks for one. So what characteristics formed by a plane mirror? Okay, class, do you remember characteristic for plane mirror? What are they? So this one mark. Okay, so what can you say? So you can write any of this answer. You can say it is upright. Okay. Fu Xuan Ling, it is not real. Okay. Upright, same size with object, laterally inverted, mean right goes to the left and the left appears on the right. Okay, laterally inverted. Or you can say it is virtual. Okay, so answer is upright. Yes, means one. Laterally inverted, correct. Jinjie. Same size as object. Yes, very well. Wei Liang. Fu Xuanling, it is not real. It is virtual. Okay, for plane mirror, it is virtual. Okay, so if you got it right, you can tick on your answer. If you get it wrong, please do the corrections. Okay, now the ray diagram. Some of you facing a problem in drawing a ray diagram, either for mirror, either for lens. Okay, so what do we have here in question C? Diagram 1.2 shows an incomplete ray diagram. So they give you the plane mirror, they give you an object, and they give you two incident ray. Okay, so complete the ray diagram and show how the image is formed. 3 marks. Okay, very much. So the mark is 3. So how to score these 3 marks? Okay, can you try to draw the ray diagram first if you didn't try them yet? Okay, try to construct the ray diagram now before I show you the complete drawing. Okay, you can work with your pencil and your ruler as well. Remember, no free sketching, no hands free. A ruler and a pencil is a must here. Okay, so how to construct the ray diagram? If you have finished, you can check your drawing. Okay, so these two incident ray is given as your guidance. So first, what you can do, you can extend this line, which is travel parallel to the axis of the mirror. Okay, second, you can draw the normal line for the second incident ray. So this is the dashed line show to you the normal. Okay, the normal for the first incident ray, and this is the normal for the second incident ray. Okay, so remember this is reflection. So in reflection, remember angle of incidence always equal to angle of reflection. Okay, so this is the reflected ray. Okay, so what we do next, we prolong, we extend this line to the back of the mirror. So now you can see this is the intersecting point between these two lines. So where our image form at. Okay, very simple. Then you can write our image is formed there. So the first mark when you draw this line, okay, when you draw the normal for the first incident ray. Second, okay, when you show the second reflected ray up here. And the third mark is where you draw your image at. Okay, so this is the complete drawing for the ray diagram on how an image is formed for plane mirror. Okay, are you clear, class, with the drawing? Okay. Next, we go to question D. Now is the application of mirror. Okay, you can see diagram 1.3, there is a junction, okay, in which car A is turning to the right, okay, while car B is moving towards the junction. So these two cars are going to meet. Okay, the driver in car A cannot see the incoming car B because his view is blocked, okay, by a row of shop houses. Okay, I believe you used to experience this when you are inside a car, when your father or your mother is driving. When you are at the junction, sometimes our view is blocked by the shop lots or houses around the junction. So to overcome this problem, a suitable mirror is need to be placed at the proper position. So the question is, where to place the mirror at this junction? Okay, you mark the location with X. Okay, so you can mark the area, or you can mark with the label X in which position is the most suitable to place the mirror at. Okay, and then you have to give one reason for your answer. Okay, so first, where to place the mirror at. So this is our junction, you can see clearly. So we place the mirror here. Okay, we place the mirror here. Okay, so did you get the correct spot, the correct mark? Okay, now give one reason for your answer. Why we place the mirror here, class? Can you state the reason why mirror is placed there at X? You can go back to the problems facing by the driver earlier. So what? Teacher, I want to copy back the diagram. Which diagram? The previous question. Is it this one, Guan Heng? Okay, if you cannot catch it, you can take the screenshot first. Okay. If you miss any of this slide later on, you can take the screenshot, and then later you can refer back to the to the picture you have screenshot earlier. Okay, are you done, Guan Heng? All right. So incident ray, this is the intersecting point where our image form at for the plane mirror. So the image, you can see it is upright, okay, laterally inverted, and it is virtual plus same size as the object. Okay. Okay, let's go back to this question. So the mirror has placed at position X. Okay, now can you give one reason, class, why we place the mirror here at position X? For what is the mirror should be placed there? So the reason is so that the image of car B can be seen clearly by the driver of car A. So as we place the mirror here, now driver A can see the image of car B which has been reflected by the mirror there. Okay, so due to reflection, it is now able to see the image of car B. So he will take an extra precaution and take a safety movement when he is about to take the corner. Okay. Okay, then question 2. State the most suitable type of mirror to be used. So what type of mirror is supposed to be placed there? Is it plane mirror? Is it convex mirror? Or is it concave mirror? Okay, Wei Liang, yes, can see by driver A and B. Okay, you are done. Thank you. So the reason is so that image of car B can be seen clearly by driver of car A, because in the question earlier it stated that the subject is car A. Okay, the problem is facing by car A. So we want to help the driver in car A to solve the problem. So by placing the mirror at X, so image of car B can be seen clearly by driver A. Okay, convex mirror, Jinjie, we are talking about mirror here. Okay, mirror, not lens. Okay, so your answer must be convex mirror. If you write convex, accepted. But if you write convex lens, it will be wrong because mirror and lens is a two different thing. Okay, please be careful. Okay, between mirror and lenses. We are now discussing about mirror. So the answer is either you just say convex or it is convex mirror. Okay, why we choose convex mirror? Instead of plane mirror or concave mirror, why we choose to place convex mirror at position of X? Why do you say convex mirror? Okay, Dylan also say convex. So what is the reason of choosing a convex mirror to be placed at X? Okay, so what do you say? Jinjie said large field of vision. Okay, while Wei Liang say enlarge the image. So which one is the correct answer? So convex mirror is used to widen, okay, to widen the field of view. Okay, it is not to enlarge the image, Wei Liang, but to widen, okay, to widen the field of vision. So the answer is wide field of vision, accepted. Larger field of vision, yes, true. Enlarge the image is wrong. Okay, wide the field of view or field of vision. Okay, next, question 4. Okay, state one other characteristics of the suggested mirror in 1D2 for the driver of car A to see a clearer image. Okay, now we say we choose convex lens. So what other characteristic of this, just now we choose convex mirror, okay? So what other characteristic of this convex mirror so that the driver can see a clearer image? Okay, clearer image. Our point is to produce a clearer image. So what is the characteristic of this convex mirror so it can produce a clearer image? Want to use a big mirror or small mirror, or how? The characteristics. Okay, just now we choose convex mirrors because it will help to widen the field of view. Okay, now how about the characteristic? Okay, Dylan say larger focal point. Okay, larger focal point. Larger focal point mean greater focal length. Okay, greater focal length. Any other answer? Okay, any other answer other than larger focal point which is mentioned by Dylan? Long focal point. Okay, long focal point. Upright image. William, you please read the question carefully. Okay, it is not asking about the characteristic of image, but it asks about the characteristic of the mirror itself. Okay, the characteristic of the mirror so you can see a clearer image. Okay, so what can we write? Okay, you can say use large size of convex mirror or bigger diameter of convex mirror or yes, larger focal length accepted. Okay, large size of convex mirror. So the image will appear to be clearer inside the mirror. Okay, did you get it, class? Larger size or bigger diameter of convex mirror. And of course, yes, long focal length. When the diameter is bigger, of course, definitely the focal length will be longer. Okay. Okay, next. Okay, that's all with question 1 on mirror, plane, and convex mirror. Okay, now let's move to question 2. It shows diagram 2.1 image, okay, of a point marked 2 meters in a swimming pool as seen by an observer standing near the pool. So you please read the information carefully to get the whole picture. What is this question about? Okay, the point appears shallower than the real depth. So you can highlight that. The point appears shallower than the real depth. Okay, so I zoom for you the diagram 2.1. So this is the 0.2 meter. 0.2 meter means the actual depth. Okay, the real depth. Okay, the real depth of the object. And this is where the observers stand at, and the dashed line shows how the image appears in his eye. Okay, it's appear to be shallower than the real depth. So 0.2 meter we said as a real depth. Image seen, so we call this depth as an apparent depth. All right. Okay, now question A1, name the light phenomenon that caused the observation. Okay, what is the light phenomenon involved in this study? Question 1, mirror is involved with reflection. How about this one? When the light travel from water into air. So the keyword is the light travel from two medium of different optical densities. So what are the phenomenon? Okay, Means one say refraction of light. Jin Qian also say refraction. Dylan also say refraction. Yes, it is refraction. Okay, refraction. Light phenomenon is refraction. Okay, now question 2. Explain how the image of the point marked 2 meters appear shallower. Okay, so how to write the explanation? 3 marks. Okay, so how do you explain this? 3 marks. How the image of the point marked 2 meters appear shallower. Why the observer seen a shallower image compared to the real object? Yes, Zwanza, it is refraction. So how to write your explanation? So how to begin? Where do we begin your explanation? First, you can talk. Okay, the light move or travel from where to where? Okay, Guang Heng say here, light travel from less dense medium to a denser medium. Is it less than to denser? Where is the light travel from? It travel from the object. Okay, from the object into the eye of the observer. Where is the object now? The object is inside the water. Okay, and the observer is next to the pool. Okay, the surrounding is air. So actually light travel from where to where? From water into air. So the light travel from denser medium to a less dense medium. See the arrow, one hand. Okay, if you look at the diagram, you can see the arrow. Okay, the arrow shows in which direction the light travels. So it travels from water. Okay, more denser into air, less dense medium. Okay, so first, light travel from higher density to lower density medium. Okay, the light travel from water into air. Okay, first point, first mark. Okay, then what's next? What's next? How to write the second point. Okay, now you know light travel from water, higher density, into air, lower density, medium. Okay, then next, what happened, class? So what happened next? Velocity of light increase in lower density, medium. Okay, light travel faster in air compared in water. Okay, so we say the velocity of the light increases in lower density, medium. So when the velocity changes, so what changes after that? The changes in velocity will cause changing in what? Changing in velocity. Remember, this is refraction. So changing in velocity will cause changing in direction. Okay, so the light refracted away from normal. Okay, so this is how you can secure 3 marks. First, light travel from where to where? Second, what happened to the velocity? Okay, so since here travel from higher density towards lower density, so the velocity increase. So when the velocity increase, it will refract away from normal. Yes, refract away from normal. That will be your third mark. 境界. Okay. So Guan Heng, you can do correction on this. The direction is twisted. Okay, this one, yes, this is mark number 3, refract away from normal. Okay, so are you clear in this, how we explain refraction? Okay, next, let's move to question B. Okay, now we have to calculate the apparent depth of the point marked 2 meters. Remember, apparent depth means the depth of the image. Another one is real depth. Real depth means the depth of the object. So you are given a refractive index of water is 1.33. So what formula to be applied here when you are given refractive index for you to find apparent depth? So here we have refractive index, which is n, and we also have the real depth. Real depth is 2 meter. You can see in the diagram. Okay, the real depth is 2 meters, so we want to find this apparent depth. When given, the refractive index of water is 1.33. So what formula we apply here, class? How to relate refractive index, apparent depth, and real depth. Can you share the formula we can apply here? Okay, Anna says here n equal to real depth divided by apparent depth. Okay, Dylan say n d, capital D, divide by small d. Okay, Jinji said h divide capital H divide by h. So actually, what letter represent depth? Okay, what letter? Depth is represented by h, not d, Dylan. Okay, so refractive index n equal to real depth, capital H, divide by apparent depth, small h. So we do the substitution where n is 1.33, real depth is 2 meters. So by this we can find this apparent depth. So what is h in meter? Okay, can you find the value of the apparent depth? H, small h. Okay, very well. Thank you. So what is h? So your first mark, when you do the substitution, you put the value in the correct places. So apparent depth is 1.504 meter.
Okay, 1.504 meter. Remember, this is a secondary value, so you can place your answer in between 2 to 4 decimal places. Okay, 2 to 4 decimal places. And the unit is in meter, 1.504 meter. Or you can write 1.50 meter. All right. Okay, next, let's go to C. Okay, now it's an application. We have diagram 2.2. It shows a reflector made by students. Okay, so the student made a reflector which is made from plane mirror. And the light rays reflected by the plane mirror is used to heat the water in a cylinder container. So you can see the cylinder is placed in front of the mirror and it contains water. Okay, but the problem is the heat produced by the reflector is not enough to increase the water temperature to a desired value. So the students need to make some modification to increase the water temperature. So our aim is modification to increase the water temperature. So what modification need to be done by the students? Okay, they give you a few aspects. First, type of mirror. So now he is using plane mirror. So which mirror is better to be used as a reflector instead of plane mirror? Okay, can you share your answer in the live chat? So the plane mirror we have to replace with another type of mirror. So what type of mirror is suitable to be used as a reflector? Okay, Jinjie said convex mirror. Wei Liang said convex mirror. Anna said concave mirror. Min Swan said concave mirror. Why there's a question mark at the back? Always question mark at the back. You must be sure with your answer. So the type of mirror is, yes, concave mirror. Okay, concave mirror. Okay, why choose concave mirror? Why choose concave mirror? Anyone? Why choose concave mirror? Okay, Min Swan, can you tell your reason, Anna, why you are choosing concave mirror? He said to converge light into one point to heat up the water quickly. Very good. Okay, remember a concave mirror will be focusing the light on one point. Okay, so focus or to converge light rays. Or you can say to focus or to converge heat. Okay, since this light ray, it contains heat. This heat is the one we use to heat up the water. So concave mirror will focus or converge light ray into heat. What happens if you are using convex mirror? Convex mirror, the light will be diverged. Okay, convex mirror. So by that, we cannot heat up the water quickly. Okay, so the answer is concave mirror. So to focus or to converge light rays or heat. Okay, very good, Anna. Okay, so I hope you're clear now why we choose concave mirror as a reflector. Okay, next. How about the diameter of the mirror? Okay, this is a bit similar to the previous question before, question 1. Diameter of the mirror should be big or should be small? Class, diameter of mirror should be big or should be small? Which one is a better choice? Should be big or should be small? So diameter, yes, we should have a large or big size of diameter. Large or big size of diameter. Why? Why must use large mirror or big mirror, big diameter? Yes, answer is big. Wei Liang, yes. For what? Why must choose big diameter of mirror? Okay, so that it can reflect or collect more light. Okay, it can reflect or collect more heat. Okay, so this is the reason. Yes, converge more heat. Okay, reflect more light. Yes, very well. Okay, either you can say reflect or collect more light or more heat. Okay, reflection more light, converge more heat. Okay. Okay, very good. Okay, so that goes for the first two questions. Okay, now we move to question number 3. Okay, question number 3. Okay, question 3. Okay, this is actually a past year SPM questions. Okay, a past year SPM questions. And some of you have do this question before. Okay, I remember Vinci used to ask me one time about this question. Okay, so diagram 3 shows a structure of a rare reflector of a bicycle created by a student. The reflector consists of identical plastic prisms. So you can highlight this info. Identical plastic prism. So you can see there are 3 plastic prism placed there, which have a critical angle of 42 degree. Okay, the plastic prism with critical angle of 42 degree. Okay, so this is the structure of the rare reflector of the bicycle. You can see this is where the ray incident at. It is now incident at an angle of 30 degree. Okay, and remember the critical angle of this prism is given 42 degree. Okay. Cikgu Liana, thank you for drop by. Terima kasih singgah di kelas saya. Okay, kelas Cikgu Liana is my friend from Academy YouTuber. Okay, class. So first question A, what is the meaning of critical angle? Do you remember about critical angle? What does it mean? Okay, you can share your answer. What is the meaning of critical angle? 1 mark. Okay, anyone? So you can refer to any references, or if you remember anything about critical angle, you can share your answer with others. Okay. So what is critical angle? Yes, very well. So it is an incidence angle when refraction angle is 90 degree. Okay, remember critical angle is an incidence angle or angle of incidence when the refraction angle is 90 degree. Okay, 1 mark for the definition, the meaning of critical angle. Okay, next, B1. Okay, on diagram 3, you have to complete the ray of light after entering the reflector. Okay, so let's take a look at our diagram. This is where the light incident at. Okay, it travel from the air into the prism at the right angle. Here, right angle 90 degree. And here at this boundary, this is the normal. So the incident angle here is 30 degree. Okay, so in which direction it will travel after come out from the prism? Okay, before that, inside here it is an A space. Okay, inside the reflector is an A space. So this is the incident ray. It incident at 30 degree of this border between the prism and the air. So in which direction it will travel after come out from the prism into air? So where will it go? Can you draw your refracted ray? So is it going to refract away from normal towards normal, or it will refract back inside the medium? So in which direction? Refract away, refract towards normal, or it will be reflect back into the medium, into the prism. So what is your choice? So how to draw? Okay, so this is what happened. So angle of incidence is 30 degree. Okay, and it's given that the critical angle of the prism is 42 degree. So now I is less than critical angle. I is 30 degree. Critical angle is 42. So I less than C, what will happen? The light will undergo refraction. So it will refract since it is moving from the prism into air. Prism has a higher density compared to air. So the light travel from higher density into a less dense medium. So it will refract away from normal. Okay, so this is the correct drawing. Did you get it right, class? So 1 mark for the correct drawing on refracted ray. Okay, now question 2. Based on your answer in B1, what happened to the ray of light after entering the reflector? Okay, and give one reason for your answer. Okay, just now we have shown this is what happened to the light ray after entering the reflector. Okay, why we draw it in this direction? Okay, meaning we have to explain in word why we draw the direction in this way. So, first we can say light refracted away from normal. First point. Okay, it travel from the prism into air. So, light refracted away from normal. Okay, second. Okay, why? Your reason, mark 2 is your reason. This is because the incident angle is smaller than the critical angle. Okay, or you can say because the incident angle is lower or smaller than critical angle. So the light will refract away from normal. Okay, anybody get this point? Who have tried it yet? Okay, how to get 2 marks for what happened and its reason. Okay, so are you doing good so far, class? Question 1, question 2, and question 3. Okay, this is just a moderate question. It's not tough. Okay, maybe it's not too easy, but still it is not tough. I believe you still can deal with it. Only every time I would like to advise you to read the question carefully, read all the information given in the question carefully before you make your decision on how to write the most appropriate answer. Okay, now let's proceed with question. Okay, there's another question. There's another question here. Question C. Okay, 3C. Okay, based on observation in 3B2, okay, now we have to make a few modifications. Okay, so that the reflector can reflect more light. Okay, again, we have to do a modification on this reflector so it can reflect more light. Okay, so these modifications are based on the aspects given. Number 1, angle of prism use. So what is the most suitable angle to replace the initial prism? Okay, if you look at this diagram, now what is the angle of the prism? The prism has angle of 30, 90, 60. Okay, this is how we look at the angle. It has an angle of 30, 90, 60. And it causes refraction, means less light will be reflected, which cause the reflector to be dimmer. So we don't want that. We want a brighter reflector. So what angle is the best angle to be used for the prism? Okay, can you share? Now we have 30, 90, 60. Okay, we don't want this angle. So what is the better angle to be choose? Anyone? Okay, what is the best angle to be choose? To replace the 30, 90, 60 prism. So you can choose a prism with angle of, Dylan say, Minson say higher than critical angle. Dylan say 90 degree. Swanser say 45 degree. Okay, we have a triangle. It has 3 angle, right? So you must mention each of these angle. You must mention 3 of this angle. Okay, tadi cikgu bagi you, I give you just now our previously we have 30, 90, 60. Okay, we don't want this prism. Okay, 30, 90, 60. So what angle is a better choice? 90 degree wrong, 45 degree wrong. You must mention all the 3 angle. So what angle? 45, 90, 45. Okay, 45 degree, 90 degree, 45 degree. Okay, which means the prism must have 2 angle of 45 degree and 1 angle 90 degree. Yes, means 1, 45, 90, 45. That is the correct way for you to write the angle of prism. Okay, so please highlight this. 45 degree, 90 degree, 45 degree. Why we are choosing this angle? Okay, state your reason. Okay, why we are choosing 45, 90, 45 to replace the 30, 90, 60 prism? Okay, what is the reason? 30, 90, 60 earlier give you refraction because I less than C. So what happened when you are using 45, 90, 45 angle of prism? What phenomenon will occur inside the prism? Can you guess? Can you think? Total internal refraction can occur. Total internal refraction. Do we have that phenomenon? Total internal refraction means one. Total internal is yes, but refraction is wrong. Total internal reflection. Or you can say I greater than C. Yes, Dylan. Okay, because by this angle 45, 90, 45, so the angle of incidence will be greater than the critical angle. I greater than C. Okay, incident angle greater than critical angle. Or total internal reflection means one, it's total internal reflection occur. Okay, not total internal refraction. We don't have total internal refraction, but total internal reflection. Okay, so can you tell me by using 45, 90, 45, what is the angle of incidence now? Okay, look at this diagram. If now we are having 45, 90, 45. So what will be the angle of incidence here? So angle of incidence will be 45 degree. 45 degree greater than 42 degree, greater than the critical angle. So by this, the light will undergo total internal reflection. It will reflect back into the prism with the same angle of 45 degree. Okay, are you clear about the reason of choosing this angle 45, 90, 45? Okay, second, number of prism used. Okay, number of prism used. Now in this diagram, you can see the boy used 3 prism. Yes, now angle of incidence 45. Yes. Okay, how about the second aspect? Number of prism used. should be a large number or a small number of prism? Use more or less prism? Large number or small number of prism? Kena guna lebih banyak prism ke atau lebih sedikit? Which one will give you a better reflection, a greater reflection? So, we use large number of prism. Okay, we increase the number of prism used. Okay, for what? So imagine you are now having more reflector. So definitely it will produce brighter reflected light rays. Okay, or more light will experience total internal reflection. So by this, the reflector will become brighter. Okay, since more light undergo total internal reflection. Okay, so this is the modification we can make on the reflector in terms of the angle and number of prism used. Okay, so let's go to the next question, D. Okay, now we have to calculate the refractive index of the prism given the critical angle C 42 degree. Okay, how to find refractive index when you are given C? So what is the formula we apply here? How do we relate C and N? C is the critical angle, N is the refractive index. So how to solve this? What formula to be applied here? Okay. Okay, very good, Dylan. Okay, more number of prisms so that more total internal reflection. You missed the word total there. More total internal reflection occur. Okay. Yes, very good, Anna. N equal to 1 over sine C. So this is the formula we apply. Okay, 1 over sine C means 1. Why using sine I over sine R? Okay, do you know what is R given? It is not given, right? So instead of finding R, so you just use the value for C given. Okay, so it is N equal to 1 over sine C. Okay, refractive index N. So we do the substitution. Sine C is sine 42. So what will be our refractive index? Can you solve for this, class? Okay, find the value of N. So what is our refractive index? So mark 1 is when you do the substitution on the equation, and mark 2 is your answer together with the correct unit. Okay. So what is the value for the refractive index of the plastic prism? 1 over sine 42. So answer is 1.49. Okay, 1.49 second mark. Okay, there is no unit for refractive index. 1.49. Okay, you don't write 1.49 degree. Okay, this is refractive index. There is no unit for it. So answer is 1.49. Okay. So that goes for question 3. Okay, the question is on refraction and total internal reflection in order to find refractive index when you are given a critical angle. Okay, now let's move to the next question, question 4. Okay, still to do with light. Okay, now we have lens, convex lens X. Okay, object O with a height of 2 centimeter. So you can highlight this. Object height 2 centimeter placed on the left side of a convex lens X. The focal length of the convex lens is given 10 centimeter. So F is 10 centimeter. Alright? So question A, on diagram 4.1, draw the ray diagram to show the formation of image. Okay, remember you are now given convex lens. So lenses involve what phenomenon? Okay, lenses involve refraction. Okay, you please be alert with this class because I find out some of you are very difficult to differentiate between mirror and lens. Mirror involve with reflection, okay, while lenses involve refraction. Okay, that is the difference between mirror and lens. So now question 4, we are dealing with lens. So the diagram is a diagram on refraction of light. Okay, so how to draw the ray diagram? You can again take your pencil and your ruler. So to draw a ray diagram coming from the object. So where will it refract to after passing through convex lens X? Okay, so how we do the drawing? First, as usual, we draw a ray parallel to the principal axis, heading to the lens. So after here, after this point, where will it refract to? Okay, remember this is a convex lens. Convex lens is a converging lens. Okay, converging lens mean the light that pass through this lens will be converged to a focal point. Okay, on the right side. So how we draw? We draw a refracted ray passing through the focal point F. Remember, the arrow must be shown. Okay. Second, you can draw another ray of light coming from the object passing through the optical center, okay, of lens X. So you can see this is the intersecting point between these two refracted ray where our image form at. Okay, I can zoom the diagram for you. Okay, first ray parallel to the principal axis, it will be refracted at the focal point. Second, a ray passing through the optical center. So it will travel in a straight line and intersect at this position. So this is the position of our image. So you can write image there. Okay, 2 marks. So where to, and then state the characteristic of the image form. Okay, so what characteristic of image form? The image is real. Okay, real. And then it appear below the principal axis while the object is above, so it is inverted. And then the size you can compare. Okay, the image has a smaller size compared to the object, so we say it is diminished. Okay, real, inverted, and diminished. Okay, clear for B. Okay, next. Okay, C. When the object is placed at a distance of 30 centimeter from the lens, calculate the image distance. Okay, and then find the linear magnification. Okay, V. Okay, V. Object is now placed at 30 cm. 30 cm, U. Okay, U is object distance. U is 30 cm and you have to find V. Okay, before that, if you look at the previous page, it says that convex lens F has a focal length of 10 centimeter. So F is 10. So U 30, F is 10. So how to find V? So how do we relate F, U, and V? Can you write the equation or the formula we can apply here? Okay, you're given F, 10 cm, U 30 cm for you to find V. So how to find V? Yes, Anna, 1 over F equal to 1 over U plus 1 over V. Okay, very good. Okay, so we write this formula. Okay, this is the formula for length. 1 over F equal to 1 over U plus 1 over V. So you do the substitution. Okay, so this is convex lens. Convex lens, the focal point is positive. Okay, so 1 divided by 10 centimeter. Okay, and here 1 over 30, U is 30. And now we can find V. Okay, can you find what is the image distance? V. Okay, I'll give you a few seconds to work with this and share what is the So what is the value for V? Okay, so have you find it, the value for V? Yes, it is 15 centimeter. Okay, so V is 15 centimeter. Okay, then how about the linear magnification? Okay, linear magnification is M. Yes, 15, Jinjie, 15 centimeter. Okay. Okay, now find the linear magnification. Linear magnification is given by M. The symbol is M. So what formula to find linear magnification? You are having the object distance and image distance. So how to relate M, U, and V for question C2. So how to find linear magnification is given by V divided by U. Image distance divided by object distance, or size of image divided by size of object. Okay, linear magnification is to know either the image has been magnified or the image has been diminished or the image has same size with the object. Okay, so how to find the linear magnification now? It is 15 divided by 30. V is 15 centimeter, U is 30 centimeter. So here, the linear magnification is 0.5. Okay, my question is, what is this 0.5 tell us? What happened to the size of the image? Okay, if you remember earlier before in class, for linear magnification, when the value is less than 1, okay, when the value is less than 1, it shows that our image is smaller than the object, mean the image is diminished. If you get M greater than 1, okay, magnification greater than 1, it shows that the image has been magnified, mean the size is bigger than the object. Okay, and if magnification is equal to 1, if you count the magnification is 1, what does it mean? Okay, it means the size of image equal to the size of object. So this is what the linear magnification tells us. Okay, the size of the image, magnified, diminished, or same size. So 0.5 means the image is diminished. Okay, before this we have write the characteristic real, inverted, diminished. So this is correct linear magnification, 0.5 shows the image is smaller than object. Okay, I hope you are clear what is this linear magnification represent. Okay. Okay, so next, let's move to question D. Okay, question D. Now we want to build an astronomical telescope. Okay, you are given another convex lens Y. Okay, just now we have X, convex lens X with a focal length of 10 centimeter. Okay, now you are given another convex lens Y with a power of 2 diopter. Okay, it has a power of 2 diopter. And you are to design a simple astronomical telescope using these two lenses, X and Y. So the first question, which lens is suitable to become the objective lens and the eyepiece? So objective lens, X or Y? Eyepiece, X or Y? And then why you say so? Give one reason. So X and Y, which one can be used as the objective lens? Which one can be used as the eyepiece? Okay, remember, for astronomical telescope, which one must have a greater power? The objective lens or the eyepiece? That one you must know first. For astronomical telescope, which one must have higher power? Objective lens or the eyepiece? Then only you can make your choice. So what do you say, class? X is for what? Y is for what? Okay. Hey, anyone? What do you say? Okay, so to make the objective lens, we use convex lens Y. Okay, while for the eyepiece, we use convex lens X. Okay, why? Why the eyepiece convex lens S? This is because, okay, so first we must know what is the power of convex lens X. For P is given 2 diopter. Okay, so to know power of convex lens P, what is the formula for power? Power is 1 divided by F. If F is given in meter. Okay, or power is equal to 100 divided by F. When F is given in centimeter. So now F for X is given 10 centimeter. So to find the power, 100 divided by 10. So the power for X is 10 diopter. Okay, 10 diopter, while Y we have 2 diopter. Remember just now I say for astronomical telescope, the eyepiece must has greater power compared to the objective lens. So that's why we are choosing X for the eyepiece and Y to build the objective lens. Okay, so this is the reason, the power of the lens. For power of convex lens greater than power of convex lens Y. So this is our reason. Okay, because power of X greater than power of lens Y. Okay. Okay, next. Okay, now you have to draw the arrangement and ray diagram for a simple astronomical telescope. So first we draw our axis and we place the two lenses here. So which one to place at the front, which one to place behind. So at the front we place the objective lens or we place lens Y. And here at this side we place the eyepiece. Okay, this is where we look the telescope at. This is where the eye of the observer at X. Okay, and then you draw the focal length for both. Okay, Y, the focal length is 50 cm. Okay, where to get this 50? From the power 2 diopter. So power 2 diopter will give you a focal length of 50 centimeter. Eyepiece, the focal length is 10 centimeter. So you draw the focal length for both. Okay, next. Okay, so this is how if you're not sure where is this 50 centimeter coming from, I show you down here. Focal length of y is FO. So 100 divided by 2. 2 is the power. So will give us focal length of 50 centimeter. Okay. So next, we draw the object for astronomical telescope. It come from a distance, further distance, very far above there. Okay. So the light coming from a further distance. So we draw a light entering objective lens, okay, at the optical center. Okay, it passes the objective lens at its optical center, so it will travel in a straight line. Second, we draw another ray parallel to the first ray and it passed through here. So what happened? It will refract parallel to the principal axis. Okay. Actually, if you continue this line, if you extend this line, the light is passing through the focal point. Okay, it passed through a focal point of 50 centimeter. So it will be refract parallel to the principal axis. So this is the intersecting point between the two incident ray passing through our objective lens. So where our first image formed at. Okay, our first image formed there at the intersecting point. And this image will become the object of the eyepiece. Okay, remember in astronomical telescope, the image formed twice. The first image formed by the objective lens will become the object for the eyepiece. Okay, so now how we draw a ray diagram from here? We draw a ray passing through the optical center of the eyepiece. So it will travel in a straight line. Okay. Second, a ray from the object travel parallel to the principal axis. So it will be refract at the focal point of the eyepiece. Okay, so it will refract here at the focal point. So you can see these two lines will be parallel. Okay, these two lines will be parallel, no intersecting point either on the right side or on the left side, which means that our final image is formed at infinity for telescope. Okay, are you clear with that? For astronomical telescope, our final image is formed at the infinity. So this is how we complete the drawing for the ray diagram of a simple astronomical telescope. Okay? So are you okay with this class? Question 4E. Okay, so now let's move to question 5. Okay, question 5. Okay, again, this is to do with light. Okay, diagram 5.1 show a light optical fiber is made of glass. Okay, first, name the light phenomenon involved at Y. So what is the light phenomenon occur at Y? So where is Y? So this is Y. Okay, so you can see this is the incident ray and this is the reflected ray. So you can see here is angle theta and at this side also angle theta. So incident angle is equal to the reflected angle theta. This one also theta. So what phenomenon we call this? What is the light phenomenon occur involved at Y? Where angle of incidence equal to angle of reflection. So what phenomenon we have there? Can you share your answer? So yes, it is. Okay, it is total internal reflection. Total internal reflection. Okay, now B1. State two changes that happen to the light ray when it passes from A into optical fiber at X. Okay, you can highlight two changes happen when the light ray passes from air into optical fiber at X. So now you're focusing on this area. Okay, light travel from A into the inner core. So what changes happen to the light ray? So number one, you can mention about the velocity. Okay, how the velocity changes when the light travel from air into the optical fiber. Dylan, it is total internal reflection. Okay, total internal reflection. Okay. Okay, B1, what are the two changes? Class. When the light ray passes from air into optical fiber at X. So first, what occurred to the velocity from air into optical fiber? So you can say velocity of light ray decreases. Mark number one. Okay, velocity of light ray decreases. Second, direction of light ray refracted towards normal. Okay, you can see again in this diagram. Okay, I zoom it again for you. So first, from air into the optical fiber, velocity decreases. Okay, and then second, you can talk about the direction. Since optical fiber is greater density compared to air, so it refracts towards normal. Okay, so these are the two changes occur to the light ray. Okay, okay, very well, Dylan. Okay, next, explain why the light ray follow the path shown in diagram 9.1 when it hit the wall of the optical fiber at Y. Okay, do you understand this question? What does it ask you? Explain why the light ray follow the path. Okay, this is the light ray moving inside the inner core. So when it reached this point, why it reflect into this direction? Okay, so what can we say? Number one, okay, light transmission of radio wave and signal. Okay, that one you refer to which one, Guan Heng? Okay, now we are discussing about number two, explain why. So number one, you can say light ray travel from denser medium to less dense medium. Okay, mean it travel from the inner core. Okay, which is denser, it travel from the inner core towards the outer cladding. Okay, outer cladding is less dense compared to the inner core. This is normal for optical fiber. Okay, the inner core has a higher density compared to the outer cladding, so that we can create a total internal reflection inside the optical fiber. Okay, second, you can say incidence angle exceed the critical angle, or incident angle is greater than the critical angle. That's what the internal reflection occur. Okay, actually this question relate to the previous one. We know that at Y, total internal reflection occur. So actually this question asks you why total internal reflection occur at Y. Okay, occur at point Y. So this is the reason. Number one, light ray travel from denser medium. Denser medium is the inner core to less dense medium. Less dense medium refer to the outer cladding. Okay, second, for total internal reflection to occur, always remember that incident angle must be greater than critical angle. All right. Okay, now we go to the long essay question. Question C. Okay, optical fiber in diagram 5.1 can be used in telecommunication and medicine. Now is the application of optical fiber. You are asked to investigate characteristic of optical fiber for use in these two fields as shown in table 5. So they give you five choices of optical fiber: P, Q, R, S, and T. And this table come together with the characteristic. First characteristic is the features of the optical fiber. So you have two choices. Either to use a single fine optical fiber or to use a bundle, okay, of fine parallel optical fiber. Second characteristic is comparison between the refractive index of the inner core and the outer cladding. So you are given N1 greater than N0, O and O greater than N1. Which one? Remember, refractive index represent the density of the medium. Okay, just now I explained to you. For optical fiber, which one has to be denser? The inner core or the outer cladding? So remember, the inner core must be denser. Denser means higher refractive index. Okay, and flexibility. Flexibility is ability to bend. Okay, ability to bend. And purity of the inner core. Very high, low, or high. Which one? Okay, so how to explain, how to choose which characteristic is the most suitable? Okay, so this is the features. Okay, number one, features of the optical fiber. So to choose a single or to use a bundle, which one is a better choice? Transformation of radio wave and signal. Okay, that is the purpose. Guan Heng. Yes, use in walkie-talkie and headphones. So which one is the features? Single or bundle of parallel optical fiber. So which one is your choice, class? So we choose, yes, bundle. Okay, bundle of fine parallel optical fiber. Why choose many instead of one? Why choose a bundle instead of one? For what? Okay, for what? So multiple and various signal and information can be sent at once. So we can send in more signal if you are having a bundle of optical fiber. Okay. Now comparison between the refractive index of the inner core and the outer cladding. Which one must be greater than which one? N1 greater than NO or NO greater than N1? Okay, transfer more signal at once. Okay, transfer more signal simultaneously. Transfer more signal not enough. You must add some more at the back. Transfer more signal at the same time. Okay. So which one must be greater, N1 or NO? Okay. N1 refer to the inner core, NO refer to the outer cladding. So N1 must be greater than NO. Mean inner core must be denser than the outer cladding. So to create total internal reflection inside the optical fiber. That is the reason. Okay. Now the flexibility. Okay, flexibility must be high or must be low. The flexibility of the optical fiber. Okay, flexibility high or low, class? So yes, flexibility need to be high. Okay, why? Why choosing an optical fiber with high flexibility? Okay, so that it can be used at a narrow space and at a non-straight areas. I mean, easy for it to be fixed in a narrow spaces and a non-straight area. Yes, it is high. Okay, reason, so it can be fit at the narrow spaces since it is flexible. Okay, it can follow the shape of the area. Can bend easily, yes. Okay, can bend easily according to the place where we want to keep it or place it. Okay, then how about the purity of the inner core? Purity of the inner core. Very high, high, or low? the purity of the inner core. So purity we choose very high. Okay, very high purity of the inner core. So why? So that the total internal reflection is more efficient. Okay, by this it will produce clearer signal, or you can say signal more clear or more clear signal. Okay, so by this, which optical fiber is a better choice? Which optical fiber is a better choice? PQRSOT. We have bundle of optical fiber, N1 greater than NO, flexibility is high, and purity of the inner core is very high. So by this, we choose optical fiber R. Okay, optical fiber R. And as usual, you can list all the characteristics or explanation for R. Okay, I just put them in a bracket, but you have to write the real characteristic and influence. It has bundle of fine parallel optical fiber where N1 greater than NO, high flexibility and very high purity of inner core. Okay, or you can write the explanation as well, as it can create multiple but it will be longer. So better to write on the characteristics. So to save more times. Okay, class. Okay, question D. Question D, diagram 5.2, 5.3 show a ray of light passing into glass and diamond respectively. So we have diagram 5.2, it shows a glass and diamond in diagram 5.3. Okay, initially this diagram show how the light incident in both medium, glass and diamond. Initially the light travel from air into glass and from air into diamond. Okay, and given the refractive index for both 1.5 for glass and 2.42 for diamond. Okay, so first calculate the critical angle for both diamond and glass. So how to find the critical angle for diamond and glass? You are given the refractive index. Again, here is to apply and equal 1 over sine C. Okay. So where for diamond, okay, we apply this formula. N equal 1 over sine C. Okay, for diamond, you just do the substitution. Refractive index is 2.42. So by this, okay, the critical angle is 24.41 degree. Can you please check for this value? Is it correct? So critical angle is 24.41 for diamond, while for glass, refractive index is given at 1.5. Again, so C is 41.81. Okay, so critical angle for diamond is less than the critical angle for glass. So what does it mean? For diamond, total internal reflection can be occur easily, okay, because of the lower critical angle. Okay, next, we have to draw the ray diagram for both glass and diamond. What happened to both as they enter both glass and diamond? Okay, look at the first diagram, 5.2. Okay, can you try to draw the ray diagram for glass? Now the air is entering at this point. Okay, and inside the glass, this is the angle of incidence as it moves from the glass towards the air. Okay, Yutong. So angle of incidence here is 30 degree. Okay, just now we calculated the critical angle for glass is 42 degree, right? 42 degree. Angle of incidence 30 degree. So what phenomenon will occur after this point? Where will the light travel after it passed through this point? Angle of incidence 30 degree. Critical angle of the glass is 42. So now I is less than C. What happened to the light? It will undergo refraction. Refract to where? Away from normal or towards normal? From glass into air. From denser medium to less dense medium. So, will be refract. It will be refract away from normal. Okay, ini critical angle 41.81. Incident ray 30 degree, less than critical angle. So refraction occur and it will travel or refract away from normal. What happened in diamond? Okay, in diamond, incident angle 30 degree and critical angle is 24.41. Okay, now angle of incident exceed the critical angle. So by this, total internal reflection occur. Okay, total internal reflection occur. Again, at this point, I again exceed the critical angle. So another total internal reflection occur here. Okay. And here also the same, where I greater than C, greater than 24.41. So this is the next total internal reflection. And now at this point, what happened? It finally emerged from the diamond. Okay, so that's why in diamond, you can see the diamond sparkle. So each of these edge, okay, where total internal reflection, it produces sparkle on the diamond. So the diamond will be sparkle at this point here. Okay, it shows a sparkling properties. Okay, class, so this is the correct way to draw the path of the ray light travel in both glass and diamond. Okay. For diamond, it undergo a few total internal reflection first, then only it emerge from the diamond. While for glass, there is no total internal reflection occur since I less than C. Okay. So M1 for refraction on glass and M2 when you show the total internal reflection inside the diamond, and second when you show the refraction where the light finally emerge out from the diamond. Alright. Okay. It's now 11:38 and we just reached question 6. Okay, so we continue. Okay, with question 6. Now is on sound wave. Okay, now we move to wave. So we are finished discussing about light. So question 6 is started with wave. Okay, diagram show a sound wave using 20 kilohertz of tuning fork. Okay, so what is meant by 20 kilohertz? Okay, 20 kilohertz is the frequency. So what is meant by this frequency, 20 kilohertz? This is an unfamiliar question, very rare to be asked a question like this. Normally they will ask you what is frequency? Okay, what is the meaning of frequency? Okay, but now they ask what is meant by 20 kilohertz? Okay, I give you a clue. Remember last time we do an experiment on ticker timer, ticker tape, to study the motion of an object which move down an inclined plane. The frequency of the ticker timer we are using is 50 Hertz. What does it mean by the frequency 50 Hertz? It shows that the ticker timer vibrates 50 times in 1 second. So we apply the same concept here. What is meant by 20 kilohertz? So it means that the number of vibration is 20,000 per second. Okay, the tuning fork vibrate 20,000 times in 1 second. Okay, that is meant by 20 kilohertz. Okay, next. Explain how the sound is produced by the tuning fork and can be heard by the human's ear. Actually, this is SPM 2018 questions, 2018 or 2019. 2019 if I'm not mistaken. One essay question on sound wave. How sound produced by the tuning fork can be heard by human's ear. 3 marks. Okay, so either 3 or 4 marks will allocate here. So first, what can we say? When the tuning fork is hit, so what happened? It will vibrate. So we start our point with the vibration of the tuning fork as it was hit. Second, when the tuning fork vibrates, so what happened to the air molecule in front of it? It will also vibrate. Okay, the vibration of the tuning fork will vibrate the air molecule at the front. So this will produce compression and rarefaction region. Okay, remember we are talking about sound wave. So when the molecule of air are vibrate, it produces compression and rarefaction. Okay. Next, direction of oscillation. So in which direction the wave propagate? So sound wave is a longitudinal wave. Okay, so the direction of oscillation of the air molecule is parallel to the direction of propagation of sound wave. This is point number 3. And then what happened? Along with the movement of the wave, it carries an energy. Okay, so energy is transferred and our eardrum vibrates with the same frequency of the sound produced by the tuning fork. Okay, so this is how we explain how the vibration is produced by the tuning fork and how the sound wave can be able to be catched by human's ear. Okay. So 4 marks you can get here, but maximum is 3. But normally for explanation, it allocates 4 marks. Okay. Okay, now in question C. Okay, we have the diagram again. It shows propagation of wave produced by a sound tuning fork. And there is a value given here, 150. From this point to this end. Okay, 150 centimeter. And C1, based on diagram, what is the frequency of the sound wave when the speed of sound is 300 meter per second? Okay, class. So you are given the frequency, you are given the speed 300, and from the diagram actually you can get the wavelength for us to find the frequency. So before we find the frequency, what is the wavelength of this sound wave? Okay, so you refer back to this diagram. How many wavelengths involved here? So this is the first wavelength. This is the second wavelength. And this is the third wavelength. Okay, so altogether, there are 3 wavelengths involved here. Okay, 3 wavelengths. Lambda 1, lambda 2, lambda 3. So 150 cm divided by 3. So it will give you the wavelength of the sound wave, which is 50 centimeter. Okay, the wavelength is 50 centimeter. So now how to find frequency? We have speed and wavelength. How to relate them with frequency? So what formula we apply? V equal to F lambda. Okay, V equal to F lambda. So which means F is speed divided by wavelength in meter. Okay, remember wavelength must be in meter. So because this speed is given in meter per second. Okay, so the wavelength also need to be in meter. So the unit will be the same. So frequency is 600 Hertz. Okay, 600 Hertz. Is it 600 Hertz? 300 divided by 0.5. Okay, 600 Hertz. 3 divided 0.5. Yes, 600 Hertz. Okay, second, what happened to the speed of sound when the vibrating tuning fork is immersed into the water? So how is the speed changes? Initially, the tuning fork vibrate in air and now we bring it to water. So what happened to the speed in water? Sound wave, speed of sound wave in air and speed of sound wave in water. So what happened to the speed of sound wave in water? Was it increase, decrease, or no changes at all? What do you say? Speed of sound in water. Increase, decrease, or no changes at all. So what do you say? Speed of sound in air and speed of sound in water. Increase, decrease, or no changes. So in water, what happened to the speed of sound? It is higher or increases. Yes, it is increased. Vinci, Dylan. Speed of sound increase in water. Remember class, sound wave travel the fastest in solid, followed by liquid, followed by air or gas. It is opposite to light wave. Okay, light wave travel fastest in vacuum or in air, followed by liquid and the lowest in solid. They are opposite. So we are talking about sound wave. Speed of sound wave is the highest in solid and lowest in air. Why? Because this sound wave, it need a medium. Okay, it require a medium to propagate. So in solid or in liquid, we have more number of medium compared to air. So that's why sound wave travel fastest in liquid compared to in air. So the answer is increases or higher. Welia, it's wrong. It is increases. Okay. Okay, next. Okay, now we have diagram 7.1 to determine wavelength of monochromatic light wave. Okay, 7.1 we use a blue light and 7.2 we use a red light source. Okay, here we use blue light and this is how the pattern of the fringes appear in the white screen. Okay, and for the red light, you can see the fringes is wider from one and another. Okay, and this is the distance given from this point to the other end. Okay. So what is the question that follow? Okay, this one you can read. The separation between two slit A and the distance between double slit and the screen D in both diagram are constant. Now A and D are constant. Okay, the dark and bright fringes are produced after the light passes through the slit. Okay, the first question, what is meant by monochromatic light? Monochromatic light. Mono means what? Mono means one, single. So what is monochromatic light? Light which has one wavelength and one color. Okay, you must mention both. One wavelength, one color, or you can say a one frequency. Okay, but normally we write about the wavelength and the color. Monochromatic means light with one color and one wavelength. Okay. Second, why are dark fringes formed on the screen? Why you can see there is a dark fringes there? Dark fringes on the screen. The dark fringes represent what? Okay, so you must know what phenomenon involved here. So the dark fringes represent constructive interference, okay, or antinodal point. Okay, antinodal point or constructive interference, where the crest meet with another crest or the trough meet with another trough. So constructive interference. Okay, dark fringes mean obvious. The light is focusing on that point. Okay, that's why dark fringes form there. Okay, next, C. So based on the pattern of the fringes formed in diagram 7.1 and 7.2, state two observation about the distance between the consecutive fringes for red and blue light. Okay, so what what observation we can see? So first you can say the distance between consecutive bright fringes for red light is longer. Okay, you can see obviously the fringes for red light is longer compared to the blue one. Okay, and second you can say for both light, for the same light, okay, the fringes are constant. The distance between consecutive fringes are constant. See, they are the same. For both the blue, okay, the distance is the same, and also for the red light. Okay, the distance between fringes are constant, the same. So first you talk red longer than blue, and then in both the distance between the next fringes to the others is constant. Okay. Okay, then D, state relationship between the wavelength and the distance between the consecutive bright fringes in this experiment. So what can you say about the wavelength and distance between consecutive fringes? Red and blue, which one has a longer wavelength? Remember the 7 spectrum, red and blue. Red has the longest. So we know red has the longer wavelength and the distance is longer. So you can say the longer the wavelength, the longer the distance between consecutive bright fringes. Or you can say when wavelength increases, distance between consecutive bright fringes increases. Okay, then E1. Okay, what happened to the distance between two consecutive bright fringes if now the separation between two slits increases? Okay, so this is the separation of slit. Okay, this is the separation of, when it is widened, when the split is widened, what happened to the distance between fringes? What can you say? So this is A and this is X. Okay, so what is the relationship between A and X for interference of light? So they are inversely proportional. So you can say when the distance between the two consecutive, when distance between split increases, so the distance between two consecutive bright fringes will decreases. Okay, it shows an inversely proportional relationship. A and X. Okay. Okay. Now give a reason for your answer in E1. Okay, why you say X decreases when A increases? This is because, as I mentioned just now, they are inversely proportional. Okay, A and X is inversely proportional. Okay, so what phenomenon occurs in this experiment? What phenomenon occurs? Reflection, refraction, diffraction, interference. So it is to do with interference. Okay, interference of light wave. Okay, interference of light wave. Okay, I'm afraid we are running of time to continue with the next question because you are having another session, right? So how can we continue in next Wednesday? Before that, we finish with F first. Okay, we finish with F first. Now it's to do with calculation. Okay, distance between a young double slit and the screen is 3m. So you must know what is this 3m refers to. Was it A, X, or D, or lambda? And then the double slit is used, has a slit of separation 5.10 -4. So what is this represent? A, X, or D, or lambda? So you are asked to find the wavelength. So we are finding lambda here, the wavelength of the red light. So how to do this? So this is the value given. 3 meter is D, distance between slit and screen. And 5 times 10 -4 is A, the separation between the slit. Okay, and X is 1.5 times 10 -2 divided by 3. So where to get this from? You can find from the diagram. Okay, this is the total length for the fringes and how many fringes we have here. So we have 1, 2, and 3. Okay, 1, 2, and 3. Actually, this is the X. Okay, so distance between one fringes to another. So 1.5 times 10 negative 2 divided by 3. So x is 5 times 10 negative 2 meter. So by this, we can find lambda by applying this formula. Ax divide d. Okay, Ax divided by d. So do the substitution. A 5 times 10 negative 4 x in meter. Okay, so 0.005 or 5 times 10 negative 2 and d is 3 meter. So all the value are in meter. So by this, the wavelength of the red light is 8.33 times 10 negative 7 meter. Okay, 8.33 times 10 negative 7 meter. Okay, so I think we stop here first because it's already 3 minutes before 12. And I know you have admits after this for Akid, if I'm not mistaken. And see also you have Bahasa with Cikgu Siti. So class, what do you think of today's lesson? Are the question tough? So in next discussion, we continue with question 8 until question 50. I'm sorry I can't finish with you with all the question. I plan to do until question 9, but it seems that in some question, I need to give you a brief explanation so you will get the point clearly. Okay, so I hope in the future is this kind of question come out in the SPM. Who knows? We never knows. It might come. Okay. Because all the question which is discussed in the module is the not to say it is a spotted, but it is a frequently asked question which is popular in this year 2020 SPM trial in most states, and some of them also is a past year SPM question. So it is actually an SPM format questions. So I hope by what we are discussing today, it will help you to added your further understanding on topics of involving light and wave. Okay, do you have any further question? If you do so, you can text me either in the Telegram or in WhatsApp or WeChat. Okay, and please feel free to ask anytime. Okay, please spend your time on doing more exercises on your own. We all teachers will help you, will give us our best to help you in your preparation. But the most important is you yourself must be well prepared. So by that, I wish everyone have a good, a well preparation. Please manage your time wisely, get enough rest, get enough sleep. Okay, don't stay up too late, but don't be too relaxed. Okay, thank you for your effort and thank you for your time. So if there is no more questions, so I hope to see you in the next lesson. So we continue with, in the next lesson, we continue with question 8 until question 15. Okay, Yutong, thank you very much for attending. The rest of you also, thank you very much. So I think you can prepare to move to the next lesson, whatever the subject is. And please, again, take a good care of yourself. Okay, stay healthy and stay hydrated. Okay, thank you, Dylan. Thank you very much, everyone. So I guess that's all for now. Okay, I'm sorry if there is anything I lack in this discussion. If there is any problem, you can come back to me anytime. I will feel very pleased to help you. Vinci, thank you. Jingqian, thank you, everyone. Okay, so that's all for now. Assalamualaikum for the Muslim and bye-bye. See you again next time. Thank you, Jinjie.